left last time, okay, and then teach you a little bit more on distributed programming. I think we're almost 20 minutes late. I think we were stuck with this. Yeah, let me share my desktop. I start sharing my desktop. Uh, I want you to actually go back to the point where we were in the last class, okay? And then I'll try to teach you now a few more issues relating to distributed computing, and then show you how practical distributed programs are developed, okay? In the process, I'll also start introducing the cloud computing. In an indirect way, I will start introducing the first level of concepts in cloud computing. Uh, but before I do that, last time we saw this program. I just go back to the program and do the okay. I'm assuming again everybody is able to get my desktop. So this is where we were last time. Okay, this is where we saw the client-side program, where we actually saw the principles of how we write the distributed programs. We open the socket, client side we open the socket. Here is the socket class which is coming from this java.net, and then we open the socket connection to the server side, and the server is listening for the connections on port number 8127. So this is the client side. Client is just writing out the line that it has read from the code, and just writing out this message, be out write. This is a buffered output write, got out from the socket object, and you're writing this message, send message across. Okay, this message is being sent across to the server side. Okay, the server is printing the message as it is received by the client. Okay, this is a simple program that we wrote. In fact, we saw this program running on the other side of the server. Okay, this is where the server is running 10.6.9.81. This is the server address. So this is where we went and then wrote our server program. I slightly modified the server program this time to just show you that the real server will be in a continuous loop. For example, you can see here somebody was asking this question, okay, last class. So we'll start modifying this program in multiple ways to understand what are the challenges of writing the distributed programs. As you can see here, the server socket is opened here. As you can see, the server socket SS is open. We are making the server socket listen on this port number 8127. Okay, and while true, that means this will be in a continuous loop till you come out of this. This server will keep on listening now. Just put this while true and then have this server listen repeatedly to the client request. Different clients can now send requests to the server, and the server will keep on listening to these requests, because as you can see here, this whole loop is in a continuous loop now. Okay, it will keep on reading whatever the clients. If there is a different client that connects to it, it will read what that client is sending. Once you have opened this new server socket here and made the server socket listen to this port number 8127, okay, then you're going to use this for accepting the incoming requests of the server. So the client, if there's another client that connects in, it reads that client's request. Okay. So we just made a little modification and made it as a true server. So if you actually compile this and then run this program, then you actually now this server will be continuously listening to the this will be listening to the incoming requests. Okay. Now I can actually do multiple times. Now I can from my local system. Now you can see there are two systems. This is the server side and this is one client side. Okay, this is what we saw last time. So we actually have the client running here. So if actually right? Make the client run here. You can give the name here, which will go to the server side, and the server gets printed. Now you can see the server is printing this, but it is still waiting now. So you can run this any number of times. For example, you can run on the client side again one more time, this new client, or from server client also. Then you can say again this one, it will again look at the server side here. Now server is in a continuous loop. Okay, I can use multiple machines now. I can log into another machine and still use the server address and port number from that client, and then run this program from anywhere. Any client can now connect to this server as long as it knows the client address and the server address and the port number. The server address is now 10.6.9.81 and the port number is 8127. This is like knowing the telephone number. Once you know the telephone number, the cell phone number of the server, you can always contact that server and get your work done by that server. Okay. Lot of distributed programs are written in this particular way. Actually, what you should understand is, for writing the distributed programs, the first fundamental thing is the server program is written. Now in this, the server program, which just gets the client string, whatever the client has sent, and prints it saying that the client said this, is running on a 10.6.9.81. This is the address of the server, and the port number on which this is program is running is 8127. Okay, the client side program uses the sockets and connects to the server, and then interacts with the server by opening the socket and writing onto that socket. The server reads from the socket. When it accepts the connection, it gets the socket object, and it uses that object to read whatever has been sent by the client. Okay. Now there are multiple things that can happen here. Before I go further, I'll show you all of you must be knowing how the send mail program works. Okay, uh, you have all sent emails. How the send mail program works is exactly the same way I've written my client server program. To just show you how the send mail program, the popular send mail program is written. The send mail is a program which runs on my email to a particular machine. This is IIT Madras email server. Okay, and then you can say this email program will be running on port number 25. This is well publicized port. All send mail programs run on this port number on every machine at port number 25. So what you have to do, you want to send an email to another machine. Your machine dials into this machine at port number 25. So it basically opens a connection, telnet connection to this particular mail server. Okay, so this is what happens now. So you are opening now the connection to this particular send mail program. Now there's a socket connection that got established to the send mail program at port number 25. Okay, then now you can say hello, and you can give your server server ID here. Okay, so you can say hello god.org. Then you can say you are sending a mail so and so. These are protocols. Okay, so you can say mail okay, djram at god.org. Okay, god.org. Okay, this is whoever is sending the mail. This is a protocol. Your program connects to this send mail and then sends all the emails to this. Okay, then you can sender okay. Then you say who is the recipient of this email to. Then you put this should go to djram@iitm.ac.in. This is my email address on that other port. This is a send mail protocol. I'm just giving all the data as per how the server expects it. Okay, then you say recipient okay. Then you say what is the data for this. Okay, this is test mail that I'm sending. Okay, test mail from for teaching the Moocs course. Okay, So this is the no test that I'm giving. So I just say now it's actually with a dot. I will actually, then it says the mail has been queued up for internal delivery. Then I can, okay, from the program. Now you can see the program, the server program here is running, this mail program is running on the other machine on this port number 25. Since I know this is the place where on this particular port number the program is running, all that I did was I just opened the connection. This program opened a connection to it. As per the protocol it expects, the inputs it reads in this particular fashion. I just gave those inputs and then it accepted my mail, and it will do the internal processing of putting it into the mailbox of the particular person. Okay, this is a very extremely popular program called SendMail. This is how we all exchange emails. All the machines in the world exchange their emails to this popular program called SendMail. And the SendMail is exactly written the same, more or less. The principles of writing SendMail program is exactly the same as I just explained. How I've written my client server program. Okay, there's a client and there is a server. Client just opening the connection to the server and just sending the messages from the client side to the server side. Okay, let me just get back and see if there are any questions. We are getting good audio and video quality. Somebody please check your bandwidth. Audio not getting. Okay. Any questions? Am I actually being? Are there? I have no feedback from any of the things. I don't know whether I'm going correctly or not. All my whatever I'm doing. Hello, says no questions. So at this point, if anybody else has questions, how many of you are able to follow what I'm doing in the class? Let me do a quick this thing to just sync up, able to follow. What about other colleges? Explicitly put whether you're able to follow or not able to follow, and if you have any questions before I go further. Okay. I'm showing most of it in a practical sense. The theoretical part will get interspersed as I'm doing the practical part, because the idea of doing this MOOCs course is to show you how things work and make you actually do things. So that's why I'm going hands-on and showing you exactly how things work in the real world. Okay. What about other colleges? Are they able to follow me? Explicitly put whether you are able to follow and you are getting the feed or not. I'm on the chat. I'm looking at the chat. Can others please respond, please? Other colleges? Okay. 6K says yes. The Vijayanagaram campus also says yes. Yes. What about other colleges? Okay. So please put an explicit yes. Whoever is online, I want an explicit yes back from them. Okay. Yes. Okay. So I guess things seems to be going a little bit more smoothly now. So we can start getting little deeper as we are moving now. Okay. Now I have a question for you people. Okay. Now how easy? I'm just showing a little bit of working programs to you. Now, do you think it's very easy to make these programs? Everybody getting audio? There's a question there. Is everybody else getting my audio, please? Yes. So I think there seems to be problem only with one particular college. Okay. Yes. 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 Very clear. Okay. I have a question for you. I want to do a little bit more interactive session before I dwell much. Okay. Now, last time the question is, what happens if multiple clients actually, try to send a message at the same time? Okay. Now look at this program that I had written. Okay, on the client side, I have just written this program, new client.java. Okay. Let us understand what are the different problems that we can get into with this program. Okay. Um, I think I probably should do this. Okay, it is in this directory. Oh, sorry. Okay, so this is the program. What do you think can be some problems with this program? Can somebody point out, okay, what are the different kinds of problems that I can run into with this program, distributed program that I'd written from the client side? Okay, what could be the problems that I can get into from the client side? What are the problems that I can get into in the server side? Okay, I want you to understand now. Um, the Can you have multiple threads in new client and get the message interleaved? That's excellent question. Okay, um, somebody is asking, I don't know where it is coming from. What does PA stand for? Can you identify yourself more clearly? Vishnu Bhimvaram. Okay, so the idea is, can you have multiple threads in new client and get the message interleaved at the server? So do you want to introduce threads in the in the client side, or do you want to introduce threads in the server side? Okay, the question is, why do you want to introduce threads? What you would have got if you had actually introduced threads into this program, and do you want to introduce this threads in the client side or in the server side? Okay, now there could be multiple problems with this programs. One is, now I'm going to go a little deeper from this point onwards. The next 10-15 minutes I'll go a little deeper, and this is going to be mainly conceptual, because I'm looking at what are the different kinds of problems that I can run into uh, when I'm running these distributed programs, and why it is a challenge to write distributed programs. Okay, um, now look at this program. If you look at this program, the way this is written, what we are trying to do is just send a simple string and then have the server accept it and print it. This is a very simple thing. If the client, now what is happening between the send, I'm just sending it and I'm not waiting for any message back from the server here. Okay, so if I have to get the message back from the server, first thing, if I have to get a message back from the server, then I need to modify. So the server opened my socket and read it. I should use the same socket to write back into the socket once I've finished my work. And I should use here the same socket to actually have one more input stream reader, and then open on the socket object. Okay, on the socket I need to open an input stream also. Then I should read that input stream. Okay, now often what happens is, all this will be interspersed here. I can be sending a message, probably I have to wait till server responds back to the message, in which case comes a blocking here. As you can see here, this is non-blocking. As it has happened, this is just non-blocking. All that I'm doing is I'm just writing this into the buffered out, and then I'm flushing it out. Then I'm saying this is my first program, and just coming out. The program is coming out. Now if you have to wait, then this becomes a blocking send and receive. Okay, so there might be issues with blocking this program till I receive the server's response. Okay, if you go to the server side, yes, no, let me I need not go into the server program, or if I have it in the other machine I probably will. So I am actually, the server is still running here. Okay, so if I just have to go to the server side, I would like to ask the question, what could be the problems on the server side and how I would like to modify this program. Okay, there is a question again from Vishnu, I think, to check if multiple client messages are interleaved. Okay, now look at this statement here. I'm saying SS accept here. This will accept only one client request. Okay, and once you have got the socket object, yes. Okay, after that I'm processing based on the client socket ID. This is where the client ID is getting printed. Now I know which client request I've accepted. then I'm reading from the client socket and printing things here. Okay, right? So let us do a little bit of thinking here to see what. Is there any questions? I don't know. Okay, so can somebody answer to me on the chat box? What could be a better way to modify the server side program? First, what can go wrong with this server program, or what is wrong in the way we had written this server program? To just get a little more basics. I know somebody is saying that to check if multiple client messages interleaved. Okay, here if there are multiple client messages interleaved, how do I do that? Okay, first question is what happens during this accept call if some other client is trying to call me. Okay, right? So for a while this program, as this goes, all this while loop is executed, and then I come back here, no other client program will be accepted. Okay, right? So let me see if anybody is able to understand what I'm saying. Okay, my question is, what is wrong with this? What can go wrong if this is the way I'm writing my server program? Let me see if anybody is able to answer this question. Somebody can answer this question. What really is wrong with the way we are writing? Some client may starve. Why should some clients will starve? I don't think there is any client starvation here. Okay, the problem. Why are you saying clients will starve in this case? On what basis are you saying clients will starve here? What is the meaning of starvation here? Once once this code is executed, waiting time is more for the client. That is correct. Okay, waiting time, this is the problem. So what happens, unless this whole code is executed, you will not be able to come back and accept another client. Okay, when server is busy with client, the other clients need to wait. That's correct answer. Okay, now what happens? Okay, there are multiple things that we would like to ask now. What is the way in which this program can be modified? Okay, if you want to modify this program, then what one way we can modify this program? The minute we have accepted, the whole idea of writing this client server program is the server should be blocked for the least time when it is accepting the client request. Okay, dedicated thread for each client. Okay, so what does that's again introduce queue on the server side. Okay, what other things I can do if I introduce a queue on the server side? What other problems do I get into? Okay, this is interesting. People are following now. So I'm going to schedule. So there are lots of answers that are coming in. Okay, the minute I actually now I'm going to next class I'm going to step into the threads. Okay, this is an introduction to how you can introduce threads, but then threads can complicate things enormously more than what you are thinking. Okay, so this is just an introduction to how we are going to modify this program. I'm going to use the same program, a simple program. We'll start introducing all the complexity that is required, for working with distributed programs. Okay, I have another question. So let me finish this this thread. Okay, let me see how we can modify. So one answer that I'm getting is have a dedicated client thread. Somebody was saying that, see if I can introduce a dedicated thread for each client request. How am I going to do that? Okay, so what will I do now? I'll modify this program by just first accepting this request. Once I've got this client socket, I will just spawn another thread for handling this request. That means, so I will just indicate how I'm going to modify. This is not the actual modification that I will. That means I will stop this processing here. Okay, and what I'll do here in this code, I'm going to now introduce saying that yeah, spawn of a different thread. Spawn is not this easy what I'm writing here, but then I'm just indicating how we'd like to do this. Spawn a separate thread for handling the client request. Okay, sorry, moving forward. Then it will be over. What happens? This whole thing becomes now this whole processing that what I'm doing here. Okay, the input stream, the client ID also possibly I will put it there. Doesn't matter. So what happens is this becomes separate thread. Okay, this code will be pushed. Somebody is saying please change the color. As I told you, I'm using the Emacs editor which has a color coding. For me actually changing this will be a bit of a no, this is using the Java color coding. Okay, L3 says unable to see. What about others? Are they also not able to see? This is in red. Black on red should be visible because of color. For PA it says fine. So I think for me on this black on red is fine. Yeah, we can, others are able to see. There seems to be some problem for L3. I think L3 should see what is the difficulty, because Jntuk says it's a bit difficult. Now, see, the problem is I'm using an editor. The editor background changing of this editor is going to be a problem. Comments and keywords are not visible. Let me see if there's a way I can change the color. New window, copy. This will take some effort on my part. Comments and keywords are not visible. We are able to follow. 48 says we are able to follow. Okay. Let me continue a little bit. What I'm trying to say is this code will be pushed to a separate thread. Okay. So what I'll do is this. I'll make this as a thread program. Now I will just make the client accept. The server just accepts the thread and then push the rest of the processing on yes into this thread here. Okay. So what happens with this code? Okay, I'll modify this this code a little later and show you how this works. This is in the next class I'm going to show how I'll introduce threads and I'll show you how the thread program will work. Okay. Now there are multiple ways these threads can be created. So what happens each time a client request comes, I will create a new thread. Okay. And then that thread will process whatever the code that's part of the client request. Okay, if this client thick, that means I have to do a lot of processing. If I'm doing very little processing, for example, I'm just printing something here and not doing much when I'm getting the client request, this should be all right. Why then push this into a separate thread and then have this executed in a separate thread? Okay, but if I'm actually not, if I'm doing a lot of work as part of the processing, then I bucket a thread so that the server code which is accepting the client request is not blocked for a very long time. This is the best code, because what it is doing, just accepting the client request and then spawning off a new thread and again going back to wait for the client request. So this gets blocked for least amount of time. So as the new client is coming in here, you are able to create new threads very fast. Okay. There are issues in this. It is not that as if this is a very good solution, but I want you to start thinking now. There are multiple things that you should start thinking now, because distributed programs, this is the excitement of writing distributed programs. Okay, many things can go wrong with these distributed programs. Okay, so debugging the distributed programs is a nightmare. For example, if something goes wrong in this program, this looks pretty simple when I had executed this program, but if you have to get this program running, then you will know how much nightmare it's going to be. There are quite a few things that can go wrong even with simple distributed programs. So making them run is not very easy at all. Okay, you should understand this. I'm going to send this program and ask you to make some modifications. Then you know even touching a program that is running itself is a nightmare. Okay, I'm going to teach you some deeper concepts on this as I go along, and then tell you why we get into, when we go to cloud, things become a lot more difficult, okay, from a different point of view, and a lot more simpler from a different point of view. Okay, so both we are going to introduce as we are going further. Okay, I have one final question today. I have one question on what is wrong again with this kind of a program. Even with this program, I find that things are not no. This is like, you walk the railway reservation counter. Okay, there are multiple ways you could have done this distributed program. Okay, you walk into the railway reservation counter. You have multiple options of how the server can be made to work. Okay, one is a token system. Okay, where once you've got the token, you stand in that line and then get service there. Okay, you can also a priori make the lines so an incoming person has to decide which line is going to do, which means there are multiple servers. Okay, and every client request just goes to that server. Okay, why this? Because as the number of requests scale, okay, let us say that the way you written this code, suddenly this is actually giving the results of your 10th exam or inter exam. The server is giving the results of your 10th exam or the inter exam. Okay, that's the time. Yeah, so I'm assuming that voice quality is clear. Please connect. Something is happening on the chat box. I think somebody else is connecting on the chat box. This thing. Okay. So the server can handle too many requests. So this, see, the idea is not just the server is handling too many requests. The problem here will be, let us say if there are a million requests, this whole thing, what we call now, how this program responds to a million requests, sudden scaling of load on the server. There could be bottlenecks at several layers, and the response from the server may be extremely poor, or the server itself might crash. Okay, now the question is, how do we make the client server programs scale? And this is the thing that is different in distributed systems. Okay, no other engineering system is like distributed system. Okay, for example, every system, when we increase the scale by twice, we know that we are solving a different problem. Okay, for example, constructing a 2-storied building is so much different from constructing a 4-storied building. You double it, 8-storied is going to be different. You go to Burj Khalifa, you suddenly know that the order of scale is completely different. Okay, but in computer science, you make this program run for one client request as well as for 1 million clients. You have to design programs that auto scale for a large number of requests, and that's a real challenge. If you look at from that sense, even this program is not good. Okay, even this program, what I've written here, is not good. Okay, this still can suffer from problems. Somebody say what kind, sir? Please give the interaction to Jntuk.
It's good that you are introducing threads, sir. This is actually not covered for JNTU people, the concept of threads. So you can give
Okay.
some good introduction about it.
Yeah,
Really,
probably next class I'm going to do a bit of thread introduction.
and
Yeah.
then we can continue with the remaining logic, sir. That's what I would love to do.
Okay. So what you're saying is the threads are not done for the JNTU Kakinada. Okay. Okay. What about other colleges? What about other colleges? Is threads covered for other colleges?
I think even for them also yes.
Some of them are saying yes, some of them are saying no. I think I'm not sure. That's okay. So let me. I'm just asking this question. You know, what could be wrong even with this program? Can somebody answer that question for me? I'm just at this stage. I'm saying that even this program, from that scalability point of view, even this program may not do very well. You still need to modify this program. Can you tell me what? Am I actually getting the desktop? Yeah, I think I'm in the still desktop mode. Okay. Yeah. So yeah, I'm just seeing this program here and then server program. What is still wrong with this program? Can somebody suggest, how else I should be able to modify? First thing is, what is still wrong with this program? Can somebody tell me, even with these threads that I've introduced, what could be wrong with this program? I'm looking at the chat session. Any of the thread synchronization? What do you mean by thread synchronization? Vijayanagaram campus, somebody is typing in saying thread synchronization. Okay. What do you mean by thread synchronization? There is no thread synchronization here. I spawn off a thread immediately once I accept a request from the client. I'm just spawning off a new thread here. Okay. Once there won't be any race condition here, because all that, if I'm sharing something, then there will be a race condition. There's not going to be any race condition here. I just spawn off a new thread, it handles the client and then closes the connection. That's it. So there's not going to be any problem. Two threads are not going to race with each other. There's not going to be any interaction between the threads also. So each thread will be separate. Each thread will be executed separately. So there's not going to be any race condition. Okay. Any other answer from anybody else? Why even this program still is not a good program? Okay. Can some? Yeah, I'm seeing all the colleges. I think I would like to see if anybody from any college will be able to answer this question. Of course, I can't give a chocolate. Connection will go to waiting state. Connection will go to waiting state is what? It's not going to. That's all right, because it has to wait for the client request. So that's good for you. So if there are more requests, it can keep accepting them in this loop here. So that's a good thing to happen. Okay. Okay, let me give you the answer. Yeah, can I wait for 2 more minutes? See if anybody else has an answer for this. No, I'm not getting any more answers. Okay. So the biggest problem here is, each time a client request is coming, I'm creating a new thread and destroying that thread. Okay. Why should I be actually doing this? This is like, imagine when a passenger arrives for making a railway reservation ticket. This is the time you are accepting that his request for making a request for making a reservation. Okay, that time you are creating a person who can handle that request, and once that request is over, you are destroying that person. Is that a good model? Can now, given this explanation, can you tell me how you're going to modify this program? Can anybody now tell me how you're going to modify this program to make it even better? Will you do this in real world? You get a person, you create a person for each request that is coming in, and you will destroy the person once the request is over. Is that the way we work? We certainly don't work like that. If you have to do this, this overhead of creating a person, okay, right? So that becomes a problem, right? So what we want to do here is we want to create a thread pool. We don't want, so how we are going to modify this finally to make this really scalable. I'll just go to this place, and now I say the modification that we will do is not queue. What we will do is we will create a thread pool. We'll create a threads. We won't destroy the threads. We create a thread pool and we allocate the client request to a free. We allocate the request to a free thread. Okay, request. Uh, allocate the request to a free thread. Okay, right. Now what happens after the thread is processed? This will be a queue of threads. This queue will get back into the queue of thread. So each time you have a client request, you're going to pick a thread that is free now, assign this request. Once it handles the client request, it comes back and again adds itself into the queue. That will be the final modification we're going to make to this program to show how we can really make this scalable. Okay. Even before I do that, I'm going to do some more, changes to this program to teach you what happens if I take the server program to the cloud. Okay. Next class, I probably will start off trying to teach you a little bit of what would have happened if the server is started on the thread. I will use one of the cloud engines, okay, and I will try to start up and show you. This is running now on my server. This server program is running on my DOS Lab server. Next time, I'm going to run this on the, put it on the cloud. You should also be able to connect to the cloud and make this program print. You can make it print whatever you send as a client. You send the request to it. Okay. Then we also introduce, as part of that program, we'll introduce why cloud, what is the kind of things that you will get when you make your programs in the cloud rather than on your LAN system, and why that is an interesting paradigm and all that as part of it. Okay. I've actually, for the lab part of it, for setting up the lab part of it, we have chosen both Kakinada and Vijayanagaram colleges, Jntuk colleges, for helping them set up the lab. As we're doing it, the lab exercises will be done by them. This two CDAC Delhi people, Balaji and Devendra, will be helping me in setting up the Boss-Mole Hadoop stack. The Vijayanagaram campus actually sent me this thing saying that they had the Ubuntu Hadoop set up there, but all my exercises and everything else will be on the Hadoop part of it. I will actually put the this thing on that, and then I'll make it available. Hello? Yeah. Yeah. So somebody is asking, can we use Cloudera? Okay, there is some assignments which we are going to take it. See, you can use lots of other things for running the Hadoop assignments, but only problem with running those things is Hadoop is a complex software. So the setting it up, and then we are also going to teach you some things on how optimization works on Hadoop and all that. Okay, the biggest problem in doing all this is we will set it up and give you the stack. For these two labs, we are going to give this and take them to a project mode. What we are going to do is we will tell them some projects which they can do, interesting projects they can do. So they will be add-on. So that requires the same setup that we are giving should be available with you. Otherwise, making all the settings correct will be a nightmare. It will not be possible for you people to do that. Okay. So we are going to do that. As we go along, we're going to see much deeper material, and then we'll see how we are going to. Yes, we see the question is a lot of people. There's people are sending me the chat thing that we can also do the project. We'll see how this goes. and what is the other stuff that we can introduce as part of this course. As we go along, we will sort of look at it. Right now we have just started off. We want people to understand, some of the basic concepts as we go along, and then slowly scale it up to a level where some deeper material can be covered. Okay, and see, the other thing is the Friday 2:20 I have my research scholars synopsis meeting. This. So I will not be able to take the 2 to 3 class. So suddenly I won't 3 class on Friday because of a local commitment in IIT Madras. I have another meeting scheduled at 2:20, so I won't be able to come online at 2 o'clock on Friday. Okay, I will see if it works out for everybody on a Saturday. I will try to take on a Saturday between 10 and 12, and then cover the material. But Friday suddenly will not work out for me. This Friday will not work out for me. Okay, right. So I think with that I will now stop because I've already another commitment, but we will continue. I think hopefully next time Ramakrishna will make sure that we are just on. We are coming on time. I think the AView software is still stabilizing. I think there's some issues of logging into the system and making things seamlessly come. Okay. Yeah, this Saturday may be a holiday, so we need to work it out as we go along. Which Saturday will work out? Maybe next Saturday. But then this Friday suddenly I'm not taking the class due to, as I said, my other commitment.